Today, we're diving into the fascinating world of thermodynamics by exploring how heat and energy behave in an open versus a closed system, and our subject, a humble hard-boiled egg.
We will be comparing three different systems today. One with the lid on representing a closed system, one with the lid off representing an open system, and a third system which will also have the lid off, however it will contain a reduced volume of water. This will demonstrate a change in heat transferred to the subject of the experiment, with the subject being the egg.
Just to get our variables straight, we'll be starting each experiment with the water temperature at 100 degrees Celsius and the eggs at 20 degrees Celsius.
Additionally, this experiment will also take place at 101.6 kPa, the recorded atmospheric pressure in Montreal when the experiment was conducted.
First, let's observe the open system. Without the lid, energy in the form of heat and water vapor escapes freely into the surroundings. This demonstrates two key thermodynamic concepts: energy transfer and entropy. Heat energy moves from the hotter water to the cooler air, and the escaping steam increases the entropy, or randomness of the system. But this comes at a cost. The water level decreases over time as it evaporates.
Now, let's look at the closed system. Putting the lid on prevents the heat and water vapor from escaping the pot, thus limiting the interaction between the system and its surroundings. This will also cause an increase in pressure within the system. However, since the lid is merely on the pot rather than providing a seal, this change is negligible at around 400 pascals or 0.017 atmospheric pressure. In a closed system, the energy stays mostly contained. Steam rises and condenses on the lid and drips back into the pot. This reduces the entropy when comparing to an open system and conserves energy within the system. This in turn will keep the water at a constant temperature.
Just to satisfy our curiosity and totally not to reach our 5-minute quota, we'll conduct our experiment with a raw egg in a shallow pan. So, what does this experiment teach us about thermodynamics? The open system demonstrates how energy can be lost to the surroundings, while the closed system shows how we can conserve the energy to achieve the same goal more efficiently. Now, key terms to remember. Heat transfer describes how energy moves in between the system and the surroundings. Entropy measures disorder, higher in the open system due to the escaping steam. And in the closed system, thermal equilibrium is achieved more quickly because the heat stays contained.
After 4 minutes, the egg reached an internal temperature of 47 degrees Celsius. In order to maintain the small amount of scientific accuracy we had left during this experimentation, the lab technician decided to cut directly into the shell of the egg with his concerning abnormally large knife.
After 4 minutes in the closed system with boiling water, the egg has reached an internal temperature of 63 degrees Celsius or 336 Kelvin. Judging by the consistency of the egg as well as its internal temperature, we can deduce that the closed system is more efficient when it comes to heat transfer when comparing it to the open system with an equal volume of water.
After 4 minutes, the egg reached an internal temperature of approximately 51 degrees Celsius. Although the internal temperature of the third egg is higher than the first, it is not as thoroughly cooked. This is due to the fact that the medium used to cook the egg, which is boiling water, was in majority removed.
This occurs due to non-uniform heat transfer, which allows for hot spots to occur within the egg. This would explain why a greater internal temperature is measured in this case.
Thermodynamics isn't just for scientists in labs. It is in your kitchen too. Whether you're making breakfast or making your morning cup of coffee before the thermodynamic final exam, understanding these principles can make a world of difference. Thank you for watching